binomial theorem and doing our summary for that. With a dead pen. Okay. So, what did we start with our binomial theorem? Pascal's triangle.
No, I thought we should.
And remember that's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, etc. Okay? And what did that connect to in terms of our NCR notation? But first of all, what is that? That term is 0C0, and then we have 1C0, 1C1, and then we have 2C0, 2C1, 2C2. And I'm running out of room, but 3C0, 3C1, 3C2, 3C, whoop, too big, etc. Right? So I've got one more line in this one than I do in that one there. Okay, so that was then a quicker way of working out the coefficients. Now, from that, we learnt that anything, this meant that NC0, so whatever the number was at the top didn't matter. If you had NC0, or if you had NCN, the same number top and bottom, what was that equal to?
The 1
was equal to 1, yeah? Because it's those ones down the outside of the Pascal's triangle, okay? There was another relationship that we came up with from the coefficients of that as well.
NC1 and equals NCN minus 1.
Right, NC1 equals NCN minus 1 equals?
The row, is it?
Yeah, which is?
and
But this one's 3C1, right? And that equals 3.
Yeah.
So it's equal to whatever the value is for that row. So they're just two that you should get your head around. Then we learnt that there was a general property in terms of the symmetry. So it may not be that it was just a term one in from the outside, but there was a symmetry property. Do you remember how we wrote that? NCR equals NC, what's the symmetric?
I minus something.
N minus R, because that'll bring you in from the other side. Okay, and there was one other property written in a couple of different ways that was important, and that was in terms of finding that term based on the two above. So if we look at it in terms of the NCR notation, then we were going NCR equals, what do you notice about the numbers above?
N minus 1.
N minus 1C something plus N minus 1C something. And that one's one less than that, and that one's the same as that. So R minus 1 and R, and that was something you guys had to prove in your assessment task.
Yeah, I know.
Or if I instead treated this as being the higher value, N plus 1 CR, so now I'm treating that as N plus 1, those two are then N, And if this is r, that is still r minus 1 and r. Okay, if I have an expansion of 1 plus x to the n, how do I write that in my sigma notation? So it was equal to the sum from n equals 0, r. We used r or k?
Okay, we use k equals 0. K equals 0.
Oh, sorry,
We use k equals 0.
k or r equals 0 up to n. What was the coefficient? NC k, because it was whatever number we're putting in at that time. Then we've technically got 1 to the power of, well, n minus k, because it depends where we are on the line.
And then x to the power.
And then x to the power of k. So that was when we just had 1 here and we had like a coefficient of 1 here. So if I instead then changed it to being the expansion of something like a plus b to the n, that's where we then went, well, that's going to be a to the n minus k, b to the n. So that was the more general one, where if you had some other coefficient here other than 1, or term here, sorry, then you needed to include that. All right.
Well, isn't it b to the k?
Yes, it is. Thank you very much. Okay. Now for the next one here, I've written down, if I'm just focusing on the coefficients, and I've got 1 plus x, so I've got 1 plus 1x to the n. This is saying, what's the sum of all the coefficients? What was that special pattern here? You guys looked at this in your assessment task as well. If you were just adding up all the coefficients, remember over here that that was equal to 2 to the power of 0. And that one was 1 plus 1, which is equal to 2 to the power of 1. And that was 1 plus 2 plus 1, which is 4, and that's 2 to the power of 2. So remember, every row, the sum of the coefficients was equal to 2 to the power of n, for whatever row you're in. Alright, what was the other, so do you remember how we wrote out the expansion too? So if I had this one here, then that would be the same as NC0
X.
A
A to the n.
A to the n minus 0 is n,
And then you times it by
b to the 0, and then I'd have NC1
And your powers.
a to the n minus 1, b to the 1, all the way down, right? What kind of questions could I ask you once we knew how to do an expansion of this binomial?
Fourth term or something.
Right, the fourth term. Or the term that had x to the power of, because what was the trick? If I asked for the fourth term,
You have to count 0, wouldn't you?
Yeah, so remember the fourth term, if it was something like this, was actually x to the power of 3, right? So there was that little bit of a trick there that you had to be careful that you started at 0, right? So the other way we would ask the question was, which term has x to the power of something or other? And therefore we were looking at the sum of the powers, giving you the one that you wanted for a particular term in x. And therefore it was something to do with, usually it might be something like x plus 1 on x all to the power of 10 and working out a particular term. And there was another question about finding the term independent of x. So what was that?
X to the power of 0.
So it had to end up with x to the power of 0. So if it was just a normal expansion, it would just be the constant term, which would be, in this case, the first term. But if you had x here and 1 on x squared there, you had to again work out where those two powers added together so that you got x to the power of 0. And then we worked from there. All right, so is there anything, I'll write something about that down, but is there anything else then that you thought of that we needed to know? The one thing I haven't written down actually for both, and maybe that's the last thing we need to then pull together, is probability questions associated with either permutations and combinations or to do with the binomial. So I'll just finish up, I'll write down that last little bit about finding a particular term, and then we'll need to work out something about the probability. Sorry, I'm just going to have to go a to the x to the a and x to the b, otherwise it won't work.
Can you rewrite that?
Yeah. Yeah. And then, of course, there were things like the hockey stick, but they were specific properties to prove using your combinatorics and factorial notation. So don't forget, you still need to rely on the fact that you know that NCR is n factorial over n minus r factorial, r factorial. You've got to rely on that still.
So Mrs., is this the formula to find that particular term?
The problem is, I'm saying this would be if you had in your expansion x to the a plus x to the b all to some power of n. Because generally it's going to be something like x squared plus 1 on x. Like, so you've got to have those different powers of x to be able to do that, otherwise it's just a straight identify. And so it's hard to set up a generic thing for that. Yep.
Are they times the x to a and x to b?
The dot.
Is that
That's
that is-
times. Yeah. Just as we're timesing these two terms here. But when you times, remember you add the indices, so that's why I've got a plus there.
Yep.
Yep. So the last little bit's the probability bit.
Miss,
Yep.
what's that bit in the brackets goes right?
I'm saying if the expansion was x to some power of a
Yeah,
plus x to a different power of b,
yeah.
all then this is your power on the outside, that's connecting those there. But an example would be if I had x squared plus 1 on x all to the power of 5. Then I'm looking at my combination of, because that when I expand that out, that's actually going to be x to the 2 to the 5, that's x to the 10 at some point, right? And then when that comes down to 4, just that part there becomes x to the 8. So I'm looking at, and this one here is x to the minus 1. So I'm looking at my x squared to the power of n minus k times my x to the minus 1 to the, and in this case it's 5 minus k because I've said to the power of 5, to equal some particular power that I've nominated. But that's what I'm saying, you need this here and you need this here. That's my A and my B when I've rewritten those, right? Because they will impact when they're connected with the power from the expansion as well. If you get a bit, when we come up to some questions, I'll point it out more clearly as well. Okay, so do you remember when we did probability with permutations and combinations? I said it was the number of restricted, and it's either arrangements or selections, depending on whether you're talking about a permutation or a combination, over the number of unrestricted. So if we're talking about getting a committee together for which we have 10 people to choose from and we only want 3, then the unrestricted selections, because it's a committee, would be 10C3. But then if I specifically wanted a certain combination of boys and girls in there, then I'd work out the restricted combination on the top and that would go on top.